So this is video 4, and when we finished off last, I asked you to complete task 2, which was the blankety blank, and I also asked you to complete the table, which is just below. So if you get those ready in your booklet, what I would like you to do now is to check your answers, to correct anything that requires correcting. Please do this in a different color ink, because remember, that makes it stand out as an error that you got last time. It makes you really attend to it so that you're less likely to make that same mistake again. And obviously, if you have questions that you don't understand any part of this, then you direct those to me. So I put in red here the blanks, and I would like you to check for task 2. This is the first part, and it moves on here. You might want to pause it. And then this last one here, and this last section is responding specifically to this syllabus statement, which is why I've got it at the top. I've also put down here in blue that respiration is a very, very important unit that we cover in year 10, and that many students forget that respiration also is a reaction that requires enzymes. So enzymes are controlling all chemical reactions. It's not just digestion, which is why I put that in blue there to emphasize it. Once you've corrected those, I also want you to correct the table that you've got on page 8, or not necessarily correct, but check may be correct. And once you've done that, I would like us to now look at task 3, which is on page 5 of the booklet. And this is really underscoring this idea that a model is a representation. So I want you to show me that you understand this hypothesis that the enzyme has a very, very specific three-dimensional shape that allows it and that allows us to explain what the lock and key hypothesis is about. So I want you to do A, draw and label a diagram. This is a visual diagram. Don't just lift and copy. Okay, try to make it a little bit original if you can. Some text as explanation is required, which is what I mean by label. So not just a word, but some text there as well. And I also want you on that same task to draw a second set of diagrams that shows that you appreciate and understand what denaturation is, how we can visually show denaturation, and again, some text to support that. So that needs to be done on page 5 of the booklet. Once you've done that, what I then want you to do is have a look at task 4, which is on page 6. Now, again, this is asking you to look back and really think long and hard about the statement of inquiry, and the conceptual and the debatable parts of this are really a little bit challenging. So hopefully the factual question is quite straightforward, and that you can answer that fairly easily, and that is the most important. This idea of a paradigm shift, I actually mentioned it in video 1. It would be a good idea to research what's referred to as the induced fit model that replaced the lock and key model. And I wanted to think about what a paradigm shift is, and how that sort of works in science. You might want to think of other examples in science that this applies to, not just biology, but chemistry and physics as well. And then this debatable question, which is a real mind bender: to what extent can we observe chemical processes in a cell accurately? Now, obviously, chemical processes in a cell are happening on a microscopic level. So again, I'd like you to do some research to consider how can we know and how can we take measurements if we can't see chemical reactions taking place. And again, that's a challenging question, but I would be really, really keen to see what your ideas are on that particular question. And finally, what I'd like you to do is to complete pages 6 and 7 of the booklet, and that's going to keep you busy for this lesson.